Oh, no. What? I don't know where I put my definition.
All right, your definition sheet,
I'll just have to write your
adjacency matrix. So definition, an adjacency matrix or adjacency matrices. What they do is they show the connection between vertices. Right, so the connection between vertices, so what's adjacent and what's not adjacent to the one. So in your graph one, so 4 in your diagram one. And so I've got a graph here, it's got 5 points on it. A, B, C, D and E. Just label them around this way. And then we've got some connections. Like so. So seeing as our graph has 5 points on it, then we have a matrix. It's a square matrix. So we have a number of rows and columns, and the rows and columns relate to the points we've got. So we have a column here for vertex A, we have another column for vertex B, another one for C, D and E. So I've made my matrix a bit wider than it needs to be, but anyway. And so then we have the same thing in rows. So we have a row for vertex A, we have a row for vertex B, one for vertex C, one for D and one for E. So it's a 5 by 5 matrix this time because we've got 5 of each of them. So then what we do is we have a look and see what connections there are. So A and row A, column A and for row for A, well A doesn't connect to itself, so there's a 0 there. A connects to B, so A connects to B, there's a 1 there. A does connect to C, there's 1 way there. A doesn't connect to D, not directly anyway, I should have clarified that, direct connections. And then A also connects to E in 1 way. So we do that for all of it. So B does connect to A. It connects to itself, no. Does it connect to C? Well, yes it does, and you can see there's 2 roads there. So we put a 2 in here, because there's 2 ways you can get between those. B does connect to D, but not E. And so on, you keep doing all of that. So C connects to A, connects to B in 2 ways, doesn't connect to itself, doesn't connect to D, and it doesn't connect to E. Alright, then move to D. D doesn't connect to A, the only one it connects to is B, so all the rest will be zeros. And then E, the only one E connects to is A, and all the rest would be zeros. Alright. Now if we go down this diagonal here, but let's use a different colour. This is a matter of interest. You go down the diagonal of this, what do you notice about
They're symmetrical.
Excuse my interruption.
no worries. Okay?
They're symmetrical.
They're symmetrical, aren't they? Alright, so that's it. That's an adjacency matrix. Alright, so I've already explained that. So there's two ways, and there may or may not be more, but anyway. Alright, any questions about that?
No, pretty straightforward.
Pretty straightforward. Alright, we can of course go the other way. So an example. So we could be asked to draw a graph.
I'll go from flat. Flat? And flat. No, in a while.
God, that's amazing.
There we go. So it's a bit wonky, but anyway, do the job. Alright, so with this adjacency matrix tells us about the connection. So this is A, B, C and D. A, B, C and D. So let's put, okay, that can be A, that can be B, that can be C, and that can be D. And so we go and we look at the connections. Now what we've got here, this one up here. So A connects to itself. So if we've got any vertex that connects to itself, that means we have a loop, yes. So there's a loop there. So we know from A we've got a loop, so we know that A connects back to itself. What else does A connect to? Well, it connects to B with two ways, and it doesn't connect to the others. Alright, beneath B connects to A, doesn't connect to itself, connects to C one way, connects to D one way. Then C doesn't connect to A, it connects to B, and it connects to D. And then just to make sure we've got it right, D doesn't connect to A, yep, connects to B, yep, got that, connects to C, got that, doesn't connect to itself. And that's it,
Very straightforward.
hopefully.
Is,
Alright, so that's it
okay.
for adjacency matrices. Don't forget, like and subscribe.